This video demonstrates how easy it is to run Clearwater deployments as a set of self-contained microservices using Docker. For those not familiar with the terminology, Microservices is the name of a software architecture where complex applications are designed, implemented, and deployed as a collection of smaller self-contained microservices. Each microservice typically serves a specific, well-defined purpose, and the separate microservices communicate via a lightweight, often HTTP-based API. For example, Clearwater implements an SCSCF. This is a complex piece of function, but it can be broken down into a set of simpler, well-defined microservices, such as a service that handles SIP communication, a service that handles communicating with an HSS over diameter, a server that provides timer management, etc. This approach offers many advantages compared to traditional monolithic software architecture, especially in the areas of scalability, ease of deployment, and reusability. Docker is a containerization platform. Containers allow multiple software processes to be run independently of one another on a single compute host, without the overhead of, say, virtual machines. This is perfectly suited to microservices, allowing each microservice instance to be deployed in its own lightweight container. The video also demonstrates how you can deploy Weave Scope to provide real-time monitoring and visualizations of your Docker deployment. We start by assuming that you have a clean Docker host with Docker Compose installed and have cloned the Clearwater Docker repo. The first thing we need to do is to build the Clearwater-based Docker image, which is used as a base for all Clearwater containers. Now we can automate building the remainder of the images and spinning up an initial Docker deployment using Docker Compose. The first time you run this, it will take a little while to complete, as all of the packages have to be downloaded and installed. At the end, we can see that Docker Compose has started up 10 Docker containers, one container for each of the microservices that make up the Clearwater deployment. We'll look in a bit more detail at exactly what those services are in a minute. If at this point we load the web UI for Weave Scope in a browser, then we can watch as these containers start up. First, we see the containers being created. Then we see them starting to connect to each other. Let's pause the screen recording and take a look in a bit more detail at what this diagram is showing us. At the bottom we have etcd. etcd is a distributed key value store and is used by Clearwater for distributing shared configuration around the deployment and for cluster management. For example, there are 3 state store services in this deployment: Cassandra, Chronos, and Memcached. We can see that each of these has connected to etcd to register themselves and to check for the existence of any other nodes of the same type that they should be clustering with, although there aren't any in this deployment. Within the deployment, containers have unique IP addresses. However, in general, service discovery is facilitated by services registering aliases that can be resolved using DNS. For example, all services know that they can reach etcd by performing a DNS lookup on the name etcd. If there were multiple instances of a service exposing the same alias, then Docker's DNS server would return the IP addresses for all the instances to enable load balancing. Other services also connect to etcd for propagating shared configuration around the deployment. Clearwater has a single shared config file that can be updated on any node in the deployment, and it will be propagated to the others via etcd. Looking at the remaining containers, we can see Bono. This is a SIP Edge proxy or PCSCF and is the anchor point for all connections from SIP clients. Sprout. This implements the SIP processing parts of the ICSCF and SCSCF. Homer, a standard XML document management server used to store MMTEL service settings documents in Cassandra for each user of the system. You can see the connection here to Cassandra as well as to etcd. Homestead, this is an HSS cache. It interfaces to the HSS over the CX interface, caches the subscriber data, again in Cassandra, and presents a RESTful HTTP interface to the rest of the Clearwater deployment. Ralph. This service provides RF charging trigger function, which is used in IMS to provide offline billing. Bono and Sprout report chargeable events to Ralph, which then reports these over RF to an external charging data function or CDF. And Ellis. This is a sample provisioning portal providing self-sign-up, line management and control of MMTel service settings. Now if we start registering some subscribers and making calls, for example by running the Clearwater live test suite, then we'll see some new connections appear. We see a connection from the internet to Ellis, this is subscribers being provisioned via HTTP, and we see a connection from the internet to Bono, this is clients registering and making calls over SIP. As described above, the data store nodes use etcd for cluster management. If we switch back to our console, there is a show cluster state script which will show us the clustering information stored in etcd. As expected, there are 3 data store clusters, each containing a single node, one for Cassandra, one for Memcached and one for Kronos. This is what we expected, as there is currently only a single node of each type in the deployment. But what if we now wanted to scale up our deployment to handle higher capacity? Using Docker Compose, this is again just a single command. Here we'll use Docker Compose's scale command to scale the deployment up to have 2 nodes each of Memcached, Kronos, Cassandra and Sprout. Switching back to the scope web UI. Whilst we've been away, the UI has rearranged itself a bit to optimize its layout, but what's of interest is that we can immediately see the 4 new containers we've created. Initially they are not connected to anything, but very quickly we see them connect to etcd to pick up information about the existing clusters, and we then see the Cassandra nodes connect to each other as they begin to cluster. They are then fully integrated into the deployment and start being used for processing. Despite WeaveScope trying to optimize the diagram layout again, things are getting pretty complicated by now. However, we can, for example, zoom in on one of our Sprout nodes. This allows us to easily confirm that Sprout is now using both Memcached nodes for storing short-lived dialog state and both Kronos nodes for running timers. On the right-hand side we can see more detailed information about inbound and outbound connections to the container, the processes that are running in the container, and how much CPU and memory each is using. Finally, if we return to the console and look at the clustering information in etcd, we see that, as expected, there are now 2 fully active nodes in each of the 3 data store clusters. Thanks for listening. For more information and full instructions describing how to run the function in this demo yourselves, please head to the Clearwater Docker repository on GitHub.